Hello friends, this is Daniel from Moralis, and today we're going to talk about an exploit that happened in OpenSea. These exploits in OpenSea have become a little bit of a trend lately, but we have to remember that whenever there is money, there are going to be exploiters and exploits. This situation was related to a phishing exploit that an exploiter was using to empty people's wallets of their NFT assets. For our analysis, we are going to start with this NFT that's part of the Azuki collection. We can see that is marked by OpenSea as a report for suspicious activity. We have that this user that we are going to call original owner bought the NFT by 2 Ether a while ago. The NFT was transferred to him after that purchase. What seems a little bit suspicious is that that user transferred the NFT to another account directly, and apparently there was no ETH transfer, at least not through OpenSea. This could have been an over-the-counter transaction, which is not that unusual. The receiver of the transfer, however, flipped the NFT immediately for 12 ETH. This is a bit atypical. Let's explore the corresponding transfer transaction. We can see that the transaction was initiated by the account identified in Etherscan as fake phishing 5169. This transaction, however, was not initiated as it is typical when we are talking about OpenSea by the OpenSea Wyvern contract. This transaction was initiated by the exploiter's account calling a different contract. If we examine the transactions in which this kind of a mystery contract is involved, we can see that this transaction that we were examining before was the first one of a series of transactions in which this user, fake phishing 5169, was interacting with this mystery contract. All of these transactions follow a similar pattern and appear to have the same purpose: the transfer of one or several NFTs for 0 Ether to fake phishing 5169. In this video, we will cover how this was possible. We will understand how you delegate the permission to transfer tokens on your behalf to operators, which is called allowances. And we are going to review how the exploit worked. Follow me to it. If we check the events of the first transaction of the exploit, we can see that the transaction triggered 3 events. An approval from the owner of the NFT to the 0 address. This is housekeeping and is cleaning some approvals on the specific tokens according to the ERC 721 standard. Then we can see the transfer event from the owner of the NFT to the receiver. This is actually when the token is transferred. And a matching orders event. This is part of the Wyvern protocol, the infrastructure that underpins OpenSea, and we will cover it in detail later on. From the events, it looks as if the transfer was directly executed from the owner of the NFT. But we need to go to internal transactions to see what actually took place. In the internal transactions, we can see that the address that interacted with the Azuki collection contract was this address. No interaction was performed from the NFT owner. To understand how this is possible, we need to understand the concept of allowances in the ERC 721 standard. When we check the ERC721 template in OpenZeppelin, which is the template that most NFT projects will use, we can check for the word transfer. And we can see that it will take us to an internal transfer function that takes 3 parameters: 2 addresses, a from and a to, and a token ID. It is verifying only 2 things: that the from address is actually the owner of the individualized token that is being transferred, identified by the ID, and also that the token is not being transferred to the 0 address. That will be tantamount to Barnet. The approval is what generates the event that we saw in Etherscan of approving that specific ID for the address 0. We can also see that it is updating the balances of both the sender and the recipient, and we can see that it's transferring the ownership of the NFT and emitting a transfer event, which also is something that we saw in Etherscan. This function would be able to transfer any token that is managed by this specific contract to any address. The safety of this function is that it can only be called internally. So we have to look into the contract what are the functions that are calling these internal functions to actually see what is going on. And we can check the main one, which is this function that calls this internal transfer function, and we see that is calling another internal function that is called isApprovedOwner. And isApprovedOwner is verifying that the token exists and that whoever is making the call is either the owner, an approved operator of the owner for a specific token, or the designated operator of the owner for all tokens in the contract. Through approvals and through set approval for all, you can designate any address to be your designated operator and transfer a specific token in the case of approval, or all the tokens that you own in a contract in the case of approval for all on your behalf. Approvals are just mappings, either at the token level or the owner level that whitelists an address as an operator. Approvals are standard functions that allow us to have non-custodial exchanges and many functionality that we take for granted in both the DeFi and the NFT space. So this is standard. This is the way that things work. Continuing with our digging, we will track all approval events in the Azuki collection contract that were granted by the victim of the exploit. Fortunately, we can use Moralis to quickly index the blockchain for us. What we will need is just the topic of the event, the ABI of the contract, which we can assume is the same as the standard ERC721 template that OpenZeppelin offers. We can just get the ABI by quickly deploying the template in Remix and copy the ABI from there. We also need the contract address, and we can very easily add filters, like the filters that you can see here that filters their results to only a set of addresses. In this case, I'll limit my indexing to 2 victims of the exploit. I have already set my Moralis server to track this type of events from 2 of the exploit's victims. And we can see that this account, which is a victim of the exploit, actually granted an approval for all through this other address to be his operator in the Azuki collection. We can furthermore confirm that the address approved as operator was the one that triggered the transfer of his Azuki NFTs in the exploit. This address was approved by him on January 20th. To understand how this address was approved and where it came from, we need to understand a bit how the OpenSea project works under the hood through the Wyvern protocol. And we are going to start by digging about this address that was approved in January 20th. Let's start by checking a bit about the address that was approved as operator. From this section here, we can see that the address is a contract and that it was created through this transaction. This transaction was initiated actually by the original owner of the NFT. It interacted with this address, which is the OpenSea registry, and that contract in turn created this other contract, which we are going to call from now on the user proxy. There was another transaction later on, also initiated by the original NFT owner, this time with the Azuki collection contract that authorized his user proxy to act as operator on his behalf in that collection. When you interact with OpenSea for the first time by creating a listing, it will prompt you to trigger a transaction with its proxy registry. This will create your user proxy. Then, anytime that you create a listing in a collection, it will prompt you to trigger another transaction, this time to approve your user proxy as your operator in that collections contract. This is actually not a bad pattern. Other possible option would have been to get users to approve the OpenSea contract or any other arbitrary OpenSea controlled address to be the operator. This other option would make the universal operator a very coveted prize for hackers and a huge attack surface for the exchange. So the victim of the exploit approving his OpenSea client proxy as operator for a given collection is all business as usual. Is not a security concern. To understand how the attack actually happened, we need to understand the workflow of a regular transaction in OpenSea. This is better done through an example. Typically, a transaction is triggered by someone clicking the buy button on a listing. When someone clicks the buy button in an OpenSea listing, a Wyvern order is created. That then is submitted to the atomic match function of the OpenSea Wyvern contract along with the pre-existing order that created the listing. The atomic match function does nothing more than matching orders. As mentioned, the listing itself was created as a Wyvern order by the NFT owner, and a Wyvern order contains a series of parameters that are cryptographically signed by the owner maker. One of these parameters is the price. The Wyvern operator stores the orders, their corresponding hashes, their signed hashes, and signatures, all of these off-chain. When atomic match is called with a pair of matching orders, the Wyvern contract only checks that the signatures are correct and executes state changes, which in our case is transfer of tokens, through the authorized user proxy. How atomic match works and how on-chain signature verification works is outside of the scope of this video. But, as you might have guessed by now, it is possible to create a valid Wyvern order outside of a given operator ecosystem. These orders will not appear in the operator's UI, but are valid from a contract perspective nonetheless. Let's check a little bit the workflow of a typical OpenSea transaction. We have a summary over here. So the buyer triggers the transaction interacting with the OpenSea Wyvern contract. The OpenSea Wyvern contract retrieves from the registry the address of the user proxy. The OpenSea Wyvern contract retrieves also the platform authenticated proxy from the registry. The code of the platform is actually in this contract, and it's quite important. This OpenSea Wyvern contract also pays the platform commission and the NFT price to the seller. Its last function is to trigger state changes through the user proxy. Notice this is a normal call, so the code of the user proxy is supposed to be executed through the scope of the user proxy. So the message sender at this point is not the OpenSea Wyvern contract nor the transaction origin, which is the buyer in this case. The user proxy is performing here a delegate call to the platform proxy. This means that it's taking the code from that address, but it will execute that code within its own scope. This is something to be very careful with, and it is a step that will become important in the exploit, as we will see later on. The user proxy validates from the OpenSea registry though that it has gotten an authorized platform proxy, and then it transferred the NFTs to the buyer. This is the anatomy of a normal transaction. As we saw, a normal OpenSea transaction is initiated by an account. Here in this Ethereum transaction tracer, we can find that it started by the initiator calling the Wyvern exchange with a series of parameters. In the transaction also, we can identify the calls to the proxy registry and the calls through which value was transferred to pay for the assets and the platform commissions. We can identify when the platform's authenticated proxy is retrieved and when it is called via a delegate call in order to retrieve the code that will be executed by the user proxy. Then the NFT is transferred via the user proxy. If we check the exploit transaction, we can see that it is much longer and a lot more things are happening. If we go to the transaction tracer, we see that the transaction is initiated by the exploiter calling its helper contract with certain payload. Then the helper contract is calling a mysterious address. After that, it follows a pattern very similar to what we saw in the normal transaction, though after validating that the authenticated proxy is correct, we see that the behavior is very different if we compare it to the normal transaction. We have built a spreadsheet to see this in more detail. We see that everything looks very familiar to the normal call until, as mentioned, the user proxy validates that it got a correct authenticated proxy. I want to point your attention to this delegated call here. At this point, the user proxy is getting code from the exploiter contract. That is what a delegated call does. It executes the code in a certain address, but within the scope of the caller, which is a risky pattern, as we mentioned before. Then we can see that the proxy of the user is executing static calls, which are typically used to read from contracts, to the mysterious address once again, and I suspect this address is used for some kind of off-chain coordination or logging, and then several calls to the exploiter helper contract, including one in which what is retrieved is the address of a contract that, if we check in Etherscan, is verified as Wyvern Atomizer. This is part of the OpenSea protocol, but it is not called in any of the normal transactions I have checked. It is only called before transfer the NFTs in this exploit, immediately after a final call to the mystery address. I am convinced that the exploiter helper contract contains code that is pivotal for the exploiter's ability to take all the NFTs of an affected user's wallet in a single transaction, tricking in some way the OpenSea Wyvern system. As we have mentioned before, it is possible to create a Wyvern order outside of OpenSea that nonetheless is valid for the exchange contract that is on chain. For this, it is only needed that the NFT owner signs an order. And through phishing, the exploiter might have obtained such an order from unsuspecting victims. But an order like this by itself would have only allowed the exploiter to steal the NFT that was mentioned in the order. However, we have seen that in this exploit there were examples where the exploiter was able to empty the wallets of all their assets, or at least the ones that were approved to the user proxy in OpenSea. So I think that his helper contract, this mystery address, and the way they play with the Wyvern atomizer would have played a big role in that. So right now the point is what to do, right? If you're concerned about your listings, I would say that the best thing that you can do is not sign any messages outside of the official OpenSea website. If any email communication is asking you to sign something, just don't. Even if the communication looks as if it is from OpenSea, it's better to be conservative. OpenSea is going through a migration, or it was, I don't know if they have finished already, but apparently they were sending some emails that were asking people to sign stuff. And this might have been leveraged by the exploiter, taking advantage of the confusion. So I would say just don't sign anything that is sent to you via email. If you suspect you already did sign a suspicious message, you will have to go contract by contract in the NFT collections that you have, some assets, and cancel your approvals to the user proxy of OpenSea. You can do that in Etherscan if the projects that you hold have verified their contracts, though this will cost you gas. But it's better to be conservative, I think. So guys, this is my summary of this situation. This is Daniel. See you in the next video.